With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everybody. Here in this question we have two statements. In the first statement they have given 1 plus 2 plus 3 plus and so on plus n is equal to n into n plus 1 by 2 for all natural numbers we have to prove. Whatever the statement will prove, we have to prove for natural numbers means generally we are mathematical induction for this statement to be proved. So what is mathematical induction? Here we are using finite mathematical induction. Finite mathematical induction to prove the statement. Here we'll take the given statement as S of n and we'll prove the statement is true for n is equal to 1. We prove that the statement is true for n is equal to 1. We'll prove that the statement is true for n is equal to 1. Then we assume that the statement is true for n is equal to k. We assume that the statement is true for n is equal to k. The statement is true. This is just assumption. We won't prove. Again, we'll prove that the statement is true for n is equal to k plus 1. The statement is true. If you prove like this, so clearly, then the statement is true for all natural numbers we can write. This is what we call it as finite mathematical induction. Okay, let me take finite mathematical induction concept here and let me prove the statement 1 here. So here I am taking given statement, that is S of n is equal to, here I am taking the first statement, that is S of n is equal to 1 plus 2 plus 3 plus and so on plus n is equal to n into n plus 1 by 2. This is my statement here. After taking the statement, first of all we have to go for the step 1. What is step 1? Step 1 means S of 1 is true. Means for n is equal to 1, the given statement is true. Here I am taking n value as 1. Where I am substituting that n value as 1? In LHS as well as in RHS also we are substituting the value of n as 1. Okay, what is LHS? Nth term is our LHS. Here n is our LHS. N value we are substituting 1. RHS is right hand side part n into n plus 1 by 2. That is 1 into 1 plus 1 by 2. That is 1 into 2 by 2, nothing but 1. LHS we got 1. RHS also we got 1 only. So clearly LHS is equal to RHS. Therefore we can say that the statement is true. That is S of 1 is true. After clarifying this as S of 1 is true, then we must go for second step. What is my second step? Here I have to assume that S of k is true. So what I am writing here, I am writing S of k. What is S of k? S of k means 1 plus 2 plus 3 plus, instead of n I am taking k. Instead of n I am taking k. So here in place of n I am writing k is equal to k into k plus 1 by 2 we are writing, and we are assuming that this statement is correct. Then we are going for step 3. What is step 3? In the step 3, this is our step 2. Okay, here in step 3, what we are going to do? We are proving the statement is true for n is equal to k plus 1. So here for this, I have to get that statement is true for n is equal to k plus 1 means we are adding k plus 1th term, that is tk plus 1th term. Tk plus 1, tn here, tn is n. Clearly we can say that by seeing the question, nth term is n here. What is tk plus 1? Tk plus 1 is k plus 1. We are adding it on both sides. We are adding on both sides of step 2. What happens? If we add it on both sides of step 2, we'll get 1 plus 2 plus 3 plus and so on plus k plus 1 is equal to k into k plus 1 by 2 already there. For this we are adding again a k plus 1 here. After adding, what we should do? We should do simplification. And we have to prove that the statement is true for n is equal to k plus 1. So I am doing simplification right side. Right side I am taking 2 as LCM. After taking 2 as LCM, what happens? Here I will get k into k plus 1 plus 2 into k plus 1. This is nothing but, if I take k plus 1 common, k plus 1 into k plus 2 by 2. That is, k plus 1 means my n. K plus 1, in place of n, I got k plus 1. In place of n plus 1, I got k plus 1 plus 1. I got k plus 1 plus 1 by 2. So instead of n, I got k plus 1. Therefore, I can say that S of k plus 1 is also true. S of x, if it is the statement is true for n is equal to 1, n is equal to k, and n is equal to 2, it is true for all natural numbers, we can say. So by saying this, we can write that the statement 1 is correct for all natural numbers. The statement 1 is true for all natural numbers. Now we go for statement 2. Again, we are writing what is statement 2 here. Here we are considering a plus d, a plus 2d, a plus n minus 1 into d is equal to n by 2 into 2a plus n minus 1 into d as second statement. So here we'll take the second statement. Again, we'll prove in the same manner using mathematical induction. Okay, here we are taking second statement. In the second statement, we are writing the statement n as a plus d, so on, a plus n minus 1 into d is equal to n by 2 into 2a plus n minus 1 into d as second statement. Here also we are doing the same problem with the 3 steps only. In the first step, we are putting a value as n as 1, where we are substituting in LHS. What is LHS here? Nth term is our LHS. Here what is nth term? This is our nth term. So we'll consider nth term and we'll prove the statement is true for n is equal to 1 here. Okay, let me take LHS. What is LHS? A plus n minus 1 into d. That is, if you take n value as 1, a plus 1 minus 1 into d, a plus 0 d, that is nothing but a we got in LHS. Now we'll substitute a value of n as 1 in RHS also. I'll substitute the value of n as 1 in RHS. What is my RHS? N by 2 into 2a plus n minus 1 into d. That is 1 by 2. N value I am substituting 1. 2a plus 1 minus 1 into d. That is 0 d, it will go on. So we'll get 2a by 2, nothing but a I'll get. LHS I got the value as a. RHS also I got the value as a only. Clearly now I can say that S of 1 is true. Now we go for second step. In the second step, we have to assume S of k is true. That is, S of k, instead of n, I am writing k and I am writing the statement. A plus d, a plus 2d, plus and so on, plus a plus k minus 1 into d, a plus k minus 1. In place of n, I took k minus 1. That is, in place of n, I took k only. So here, k by 2 into 2a plus k minus 1 into d. This is our given statement. Now we are proving for n is equal to k plus 1. That is our final step. What we have to do for that? We have to add k plus 1th term. Here kth term is k is here. If I go for k plus 1, that k must be replaced by k plus 1. So what it will become? A plus k plus 1 minus 1 into d it will become. So it is nothing but a plus kd. We are adding on both sides of given statement here. Both sides, what happens if we add? This is a plus d, plus and so on. Already a plus k minus 1 into d is there. For this, we are adding a plus kd. Okay. For right side also, we are adding a plus kd. Here I am writing right side term as 2a plus k minus 1 into d. After that, I am adding a plus kd here. Now we have to simplify right hand side part. Now we have to simplify right hand side part. If you take 2 as LCM, it will become 2ka plus k square d minus kd plus 2a plus 2kd will get. Okay, if I again simplify 2ka plus k square d minus kd plus 2kd is there. There, if I subtract, what happens? It will get kd. 2a by 2. Okay, again we have to take something common. What we can take common? In the first and last terms we can take 2a common. We'll get 2a common. So here we'll get k plus 1. Next, if I take second and third terms kd common, I'll get again k plus 1 by 2. 2a into k plus 1 plus kd into k plus 1. If I take k plus 1 common, I can write it as k plus 1 by 2 into 2a plus kd. Kd means k plus 1 minus 1 into d. So instead of n, I got k plus 1 here. According to the question, this must be in the form of n by 2 into 2a plus n minus 1 into d. So instead of n, I got k plus 1. So clearly I can say that the statement is true for s of k plus 1 is true. Whenever the statement is true for n is equal to k plus 1 also, we can write the statement is true for all natural numbers. The given statement is true for all natural numbers. Now we can clearly confirm that the second statement is also true. Second statement is also true. Thank you. Thank you everyone.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.